Number 10. A generator supplies 50 kilowatts at a power factor of 0.85. What is the apparent power? So you will notice on this one I have not drawn the colors. I'm going to gradually start taking away those. You can still do that if you need to do those. Kilowatts, that's going to be real power. So let's put that down here on this leg. We know power factor is 0.85. We are looking for the apparent power. So we're looking for this dimension. Now, if I knew theta, we could work with a ratio, but I don't. So we're going to have to work from this power factor formula. I know another way to write power factor. Just as review, that is also the cosine of theta. But we don't know theta, so we can't really find the factor if we don't know theta. We could also write power factor as a ratio of apparent power on the bottom, true power on the top, or in our lingo, that is W over VA. So all of those are power factor information, but I'm going to use this 0.85 and this W over VA, and I do know a value for W, so I'm going to take out that W and put in 50 in its place. And then I can solve this equation. VA is going to get multiplied by both sides. Cancel this. So we have 0.85 times apparent power equals 50. So if I divide both sides by 0.85, I'm going to end up with my apparent power. And 50 divided by 0.85 is approximately 58.82. And since we're dealing with kilowatts, we want to deal with that also in our apparent power. So we have solved this one. And I'm not sure why I thought I had to do more. So let me move this over here and give myself a little more room. Using the power factor, we were able to solve for apparent power. Okay, number 11. Finding power factor given P and Q. A motor operates at 600 watts of real power or true power and 800 VAR reactive power. Find the power factor. So let's put power factor on here. We don't know the decimal, but we do know that power factor can be found by dividing true power by apparent power. Or for us, that's W divided by VA. Unfortunately, we don't know VA, but we do have the two legs of the triangle, so we can use Pythagorean theorem to find VA. So we have A squared plus B squared equals C squared. Or, for us, VA is hypotenuse. A squared is 600 squared. B squared is 800 squared. And then we just need to do some math. 6 squared is 36, and I add 4 zeros. 8 squared is 64, and I add the 4 zeros. And together those will give me apparent power squared. This is 100 with 4 zeros, equaling apparent power squared. And then I can take the square root of both sides. And so apparent power is going to be 1,000. And these are not kilos, they're just plain watts. Okay, and now we can substitute this back into our formula. So power factor is W over VA. And we can cross off some zeros to get 6 over 10, which reduces to 3 over 5, or the decimal 0.6. And that is our power factor. Number 12. A system operates at 10 kilowatts with a power factor of 0.9. Find the reactive power. So they want us to find VAR. Working with the power factor formula, I know that power factor is defined another way as power true over power apparent, or W over VA. So I'm going to use 0.9 for power factor. And then W is 10. VA we don't know yet. But to find it, we're going to cancel that variable. I'm sorry if you hear the tomcat. He's wanting outside. 0.9 VA equals 10. Just a minute, buddy. I'll let you out. And then 0.9 divided both sides. So apparent power is going to be 11.11. Or just to make life a little bit easier on this one, I'm going to call it about 11. And this is kilo apparent power. Now, that's going to give me this one. But we're looking for VAR. So let's go one step further using Pythagorean theorem, which translates to 10 squared plus VAR squared equals approximately 11 squared. So here's 100, 121, and then I would need to subtract here and here. So reactive power squared, and that's kilo reactive power squared, is 21. Take the square root of both sides. And so that's going to be approximately 4.84. And that is our reactive power.